Okay, so now let's practice some example. But before that, as we say, now actually there is one important result as we say, Fubini theorem. It says that when we consider double integral problem, actually it's equal to solve it by repeat integral. But so the Fubini theorem says that we have a function which contains two variables, or you could say g equals f of x1, and if the function is continuous on the region is rectangle ax between a and b, y between c and d, so you also could say that it's ab times cd. Okay, so it's a rectangle. Then for its volume, the volume is a solid, and which solid? This solid is below the curve, below the surface, g equals f of sy, and above the sy plane. Sy plane is g equals 0, and x between a and b, y between c and d. And we have a solid, and for the volume of this solid, the dot is equal to the double integral, this one. And its double integral, we have said that its definition. But it's complicated to solve it by definition. And so Fubini says that it's equal to repeat integral and this one. And so we could integrate it by x. Firstly, and after that integrate by y. And we also could integrate by y firstly, and after that integrate by x. Okay, so Fubini theory is very important. Since actually when we consider the integral, multiple integral, if it contains two variables, we will use this result to solve it. Yeah. So as we say, once you integrate by x firstly, then you could view y as a constant. So view y as a constant. And once you integrate by y firstly, then you could view x as a constant. Okay. Then if view y as a constant, so you could view it as a single variable function. So just consider single variable function. It's integral formula, and this one is the same. Okay, so it's important result. Fubini theorem, important result. Okay, so now let's practice the examples. So first one. Okay, so first one we have the function y times sin xy. So we could call it by the function g. G equals this guy. So originally we could denote by v. So originally it's the problem about double integral. The form double integral. We have the integration to integration notation. And here is our region R. Okay, it's the double integral notation. Okay, and for double integral, the notation is dA. Here, dA means area. You could view it this way. And its derivation comes from delta Aij. Remember that? Delta Aij. So delta Aij becomes dA for its notation. Okay, so originally for the double integral by Fubini theorem, we know that it's equal to. We could integrate it by y firstly. So y, here is our x, here is our y. So integrate by y firstly. So y goes from 0 to pi. And then after that, integrate by x. This is 1, 2, this one. We could solve it by this way. Right? But we also could solve it by this way. Integrate it by x. So x goes from 1 to 2. And then after that, integrate by y. But which one we will choose? Here, as we say, in this case, if you consider this one, then view x as a constant. And then if you choose this one, view y as a constant. Since our variable now is x, so view y as a constant. Okay, so it's something like this example. Here, for this one, integrate view x as a constant, so it's y sine constant, for example, let S be 2, constant, dy, first one. And the second one, by is a constant, so for example, y equals 2. For example, y equals 2, then it becomes 2 sine x times 2, so it's 2x dx, this one. Okay, so for these two questions, which one is simple to solve it? Which one? Of course this one, right? Of course this one. This one we also could solve it, but it contains polynomial, it contains trigonometric function. So actually for this one, we could solve it, but you should use the integration by part in chapter 6.1, integration by part to solve it. So it will be a little complicated. But we also could solve it. Okay, but this one is easy to solve it, right? Just fundamental theorem of calculus is enough. It's enough. So this one is better to solve it. But so now let's come back to our question. So if we integrate by x, we view y as a constant, then it's constant. It's constant. We just have one variable x over here. So of course it will be simple to solve it. Here y is the variable, s is constant, but here we have the variable. Then of course it will be complicated to solve it. So Fubini theorem says that all of them are the same, but in this case we won't choose this one. It will be, since it's complicated. It's not true. It's not wrong, but it's complicated. It's complicated. So we will choose this one. To solve it. Okay. So now let's see how to solve it. It's equal to the outside the part we keep it. We solve the inside part firstly. For the inside now y is a constant. Okay, so y is a constant. For example, as we said, set to what's the integral? So it's constant. Just keep it, but we should focus on this part. So sine, which function is derivative sine? It must come from cosine, right? So we consider cosine. Write down the form firstly. But when you consider cosine 2s is derivative, you will see it's equal to its outside and its inside. So its derivative by chain rule is equal to negative sine 2x. Keep it inside, times inside is derivative 2. Okay, and here is 2 sine 2x. So in each part we multiply by negative 1. So you will get negative cosine 2x is derivative equals 2 sine 2x. This one. So now we integrate in both sides. So this term is integral equal to this one. But by fundamental theorem of calculus, integrate firstly and after that, differentiate firstly and after that integrate, then we cancel it. Then it's equal to this term. So indeed, this term is equal to negative cosine 2x plus a constant c. This one. And then now the function is y times sine xy. So just replace 2 by y, right? Actually just replace 2 by y. Okay, so or otherwise you also could use the same argument. Sine y is constant, so just keep it or but anyway, so we focus on sine, and sine it must come from cosine xy. And when you consider its derivative, when you consider its derivative with respect to x, then it's equal to negative sine xy, and inside it is times y. Consider d dx cosine xy is equal to this one. And now it's negative y is y, so it becomes this one. And s goes from 1 to 2. And it's our solution, this part. Okay, this part. S goes from 1 to 2. Okay, so here you will see. So what's this? It's equal to 0 pi So just plug in the value 1 and 2. So it's equal to negative cosine 2y. Subtract negative cosine y dy. This one. But subtract negative becomes positive. Cosine y. So it becomes negative cosine 2y. Cosine is integral is its integral is sine, right? So it comes from sine 2y. But when you consider sine 2y, its integral is cosine 2y times when you consider sine 2y its derivative, it's equal to outside is derivative cosine 2y. Inside is derivative 2. So now here the coefficient is negative 1, so you should divide by 2 in both sides. But once you divide by 2 in both sides, here is the cosine 2y. But it's negative, so multiply by negative. Okay, so this 10. This 10 is derivative. This 10 is derivative is negative cosine 2y. So in other words, this 10 is integral in this one. Negative 1/2 sine 2y. And here plus cosine y. Cosine y comes from sine y, so sine y. And again, if you consider sine y is derivative is exactly cosine y, then it's fine. Then and the y goes from 0 to pi. This one. And what's the solution? It's equal to just plug in the value negative 1/2 sine 2 pi plus sine pi subtract negative 1/2 sine 2 0 is 0 plus sine 0 this one. And here sine 0 is 0, sine 2 pi is 0, sine pi is also 0, so all of them are 0. Okay, so when you get the solution 0, then probably you will think is it correct? Actually, it could be right. I mean, what do I mean? I mean, even you get this one, what does it mean? As we say, it means that the value below this curve and above xy plane is 0. But why do I get 0? The reason is that the reason is that probably for this curve, for this surface, there are some part below xy plane, and there are some part above the plane. For example, just as we say here, for example, negative 1 dx. Y equals x. Y equals x. Its integral, what's the integral? Its integral is x squared over 2. X goes from negative 1. So it's equal to 1 over 2 subtract 1 over 2. So it's 0. And then it means this one, right? Here is negative 1. So its area. Total area of the region is 0. The region is that some area is above the x-axis, some area is below the x-axis. So when we can, and if it's below, then it becomes, for its value, it becomes negative. So and the positive, negative, and the total sum is 0. And it's the same for this one. The study for this study is value. Some of them are above the xy plane. The sum of them are below the xy plane. And when you consider the sum, it becomes 0. Just the value below the xy plane is equal to the value above the xy plane. Okay. Yeah. So now let's see second question. Second one. And the second one is this one. And this one, okay, if we write down in this way, means that just follow this one. Integrate it by s directly, and after that integrate by t. Okay, but when you integrate by s, for this question, if you see the square root, probably when you see the square root, and then when we consider its derivative or integration, we will change it into a power form. I mean, since we will use the power rule, I mean, it's 0, 1, 0, 1, s plus t, 1 half, ds, dt. We want to solve this one. And now let's solve it. This one, so now, if it's of the form, it means that if it's of the form, it means that you could view t as a constant. So now t is a constant. For example, 0, 1, s plus 2, 1 half is ds. So what's this? Okay, so of course you could change it into u by substitution rule. Otherwise, if you see its derivative equals 1, then you could view it as this question. It has the same similar form. I mean, you could view it as this question. This one, s is square to the power of square, to the power of 1 half, How about this one? It's integral. How about this one? It's integral. This one is integral is, for its power we should plus 1. So it's 1 half plus 1, so it's 3 halves. But when we consider this guy is derivative, you will get, when you consider this guy is derivative, you will put it down, so it's this one. Subtract 1, so it's this one. Yeah, so now we divide by this one in both sides. Or you could say multiply by its reciprocal. In both sides. So we multiply by its reciprocal. Then we cancel e. So s to the power 1 half is equal to 2 over 3 times this guy. So when you consider its integral, it's exactly equal to this 10. 2 over 3 times this 10, 2 times this one. Okay, so when you consider s to the power 1 half, its integral is this one. And then now, how about this one? It has a similar form. I mean, it has a similar form. For its power just plus 1, it also has the form. This form. And then now, write down the form for 3. And after that, check the coefficient. And again, when you consider its derivative, you still have 3 halves times s plus 2 to the power 1 half. But the one, this one is coefficient is 1. It's now 1, so you should multiply by its reciprocal, 2 over 3. So in other words, you should multiply 2 over 3 this guy, right? Okay, so that's the reason why we say this 10 is integral in this one. And of course, you should plug in the value 0, 1. You should plug in the value 0, 1. And now, once you consider its derivative, indeed, put it down, then we cancel it, and for its power subtract 1 is exactly this 10. And the inside is derivative is 1, so it's fine. Okay, and then now just replace t is constant, so now just replace 2 by t. Or otherwise you could say use the same argument. Here is still 0, 1, and here t is constant, so just focus on s to the power 1 half, so it's of the form s plus t 3 halves plus 1. But again, put it down, we have 3 halves, so by its coefficient 1, so we should multiply by its reciprocal, 2 over 3. And here s goes from 0 to 1 dt, this one. And here I erase e. And now it's equal to 0, 1. Plug in the value 2 over 3, 1 plus t to the power 3 halves. Subtract 2 over 3, plug in the value 0, t 3 halves dt. Otherwise we could skip it. This one. And h10, first one, 2 over, just separate. Solve it 10 by 10. So first 10, for a constant, keep it. And this 10 is integral. Just for its power, we should plus 1. So 1 plus t for its power plus 1. 3 halves plus 1, so it becomes 5 over 2. 5 over 2. But when you consider its derivative, this 10 is derivative, you will get the coefficient, the scalar 5 over 2. So now you should multiply by its reciprocal, 2 over 5. It's 10. It's 10. I mean, this 10 is integral in this 10. This 10 is integral in this 10. If you check this 10 is derivative, put it down and we cancel it. And for power subtract 1 is exactly this one. And this 10 is subtract 2. This one is equal to, again, for its power plus 1. But put it down, we have 5 over 2, so we should multiply by its reciprocal, 2 over 5. This 10. This one. And s goes from 0 to 1. T goes from 0 to 1. 0 to 1. And finally, it's equal to 2 times 2, 4 over 15 times 1 plus 1, 2 to the power of 5 over 2, subtract 4 over 15 times 2 to the power 1. 1 to the power, actually 1 to any power is 1. So just write down by 1. And subtract 4 over 15 times 0, so it's 1 times to the power, to any power is 1, so just this one. Subtract 0, this 10. And subtract 4 over 15, subtract 4 over 15, so just subtract 4 over 15 times 2. So each of them have the 4 over 15. So we could write it this way. Okay. Yeah, so of course this part is fine. Yeah, just this part is fine, and for it's just some simple computation. Okay, so now let's see third question and the last one. Okay. Okay, I write down the question. Okay, let's see. Let's see third question. Okay. Yeah, so for third question, now if we write down in this way, it means that we integrate by y firstly. So you could view x as a constant. X as a constant in this case. And then if we view it this way, then view x, again, it's view x as a constant. View x as a constant. Yeah. Let me see. Okay. Yeah. So now let's see this one. View x as a constant. For example, we let x be 2. For example, let x be 2. Then the question becomes 1, 2, 2 over y plus y over 2 dy. It's integral, right? The question becomes this one. And what's the solution? This part is 2 times 1 over y. We separate, right? We could integrate 10 by 10. So first 10 is this one. This one. And its integral is two constant just keep it. 1 over y. 1 over y is integral in nature log of y. 1 over y is integral in nature log of y. And of course, originally we should consider absolute value. But now we integrate it from 1 to 2, so its absolute value is always positive. So this part we could skip it in this case. And this 10 is 1 over 2, so it's 1/2 times y dy. And it's exactly 1/2. Constant keep it. Y is integral is y squared divided by 2. This one, right? For its integral, we should pass 1 for its power. By its derivative, we have the constant 2, so we should divide by 2. It's 10, right? And then now, just replace 2 by x. So, what's the first one? And this term, as we said, we could write it this way: is x times 1 over y. And this term is 1 over x times y. So, this one is equal to 1, 4. And this term integrate by y, so x times nature log of y plus 1 over s is the constant, y is integral is y squared divided by 2, y squared divided by 2, this 10. And s goes from, sorry, y goes from 1 to 2, 1 to 2 dx, 1 to 2 dx, this one. And it's equal to 1, 4, just plug in the value 1 and 2, so you will get x times, nature log 2, x times nature log 2 is absolute value, this one, plus 1 over s, times 2 squared, so it's 4, 2 squared over 2, so it's 4 divided by 2, so it's 2, this 10, subtract 1, so it's x times nature log of 1, plus 1 over s times 1 square 1 is square divided by 2 dx, this one. And let me see, yeah. Okay, so now what's this? Here nature log of 1 is 0, so we should keep it, we should delete it, cancel it. And here we have s 1 over s times 2 subtract 1 over s times 1/2. 1 over s times 2 subtract 1 over s times 1/2. So it becomes 1 over integrate from 1 to 4 s times nature log 2 plus 1 over x times 2 subtract 1/2. So 2 subtract 1/2 is, or 2 is exactly equal to 4 over 2. So their subtraction, so it's 3/2 dx. Yes, and it's exactly equal single variable function case, right? Integral equation. So it's x is integral is x squared divided by 2, and the constant keep it, plus 1 over s is integral in nature log x, and multiplied by the constant keep it. This 10, and s goes from 1 to 4. This one. And finally, plug in the value. So 4 is square is 16 divided by 2 times nature log 2 plus nature log 4 is absolute value is exactly is 10. Subtract, plug in the value 1. So it's this 1 plus nature log 1 times 3/2. But nature log 1 is 0, this 10 is 0. And this 10, 4 is equal to 2 square. And the 2 square, for its power we could put it down, so it's equal to 2 times nature log 2. Just that we could simplify it. And here is 8. So finally we have 8 times nature log 2 plus 2. Here 2 times nature log 2 times this one, so we could cancel it. So we still have 3 times nature log 2. So now it's 8 times nature log 2 plus 3 times nature log 2, subtract 1/2 times nature log 2. And this term is 0. So it's 8 plus 3 subtract 1/2. times nature log 2. And it's 11. And then it's 11 is 22 divided by 2. So finally the solution is 22 subtract 1. 21 over 2 times nature log 2. Is this one. It's our final solution. It's our final solution. Okay, it's the third question. Okay, the last one, this one. So again, here you could see that here view x as a constant, so here you could separate, here is equal to 1 over s times nature log y, right? So 1 over s is constant, so for this question, actually 1 over s you could take out. It's 1 over s times 1 nature log y over y dy dx, this one, right? Because 1 over s is constant. If the variable is y, is something like this question, nature log y, x, you could view x as 2, the case 2. So it's 2 times y, this one. How to solve it? It's constant, so 1 over 2 you could take out, right? 1 over 2 you could take out. You still have this one. 1 over 2 you could take out, right? So 1 over s you could take out. But what's this? It must be a value. It's a number, real number. So it's independent on x. This 10 is independent on x. So for this 10, you also could take out, right? Now we can see the integral x. But it's a value, for example, it's a value 7 or it's a value -5. So of course we could take out, right? And then to integrate this guy. Now this guy is x, right? Okay, so now we also could write it this way. It becomes 3, 1, and take out, so we still have dx over here times 1, 5, nature log y over y dy. These two functions, they are product. So actually you could see that if the function is a product of two functions, and the one is just the single variable function, another one is another single variable function. Here the variable is x, here the variable y, then we could separate. Consider their multiplication, each of their multiplication. Yeah, it's single variable function, their integral function, their integral problem. And for this 10, it's easy to solve. It's nature log x, and x goes from 1 to 3. And how about this one? For this one, once you see y, nature log y, of course you could say that polynomial and its nature log, you could use the section 6.1. Section 6.1, integration by part. But before that, as we said, if you could solve it by fundamental theorem of calculus or substitution rule, then we could solve it. When you see a integral problem, first of all, you will think that could I solve it by fundamental theorem of calculus or substitution rule. And this one, of course, fundamental theorem of calculus, we could not solve it directly, but we could solve it by substitution rule. The reason is that, as we say, a fraction, we could write this way: 1 over y times nature log y. 1 over y times nature log y. So it's a product of two functions. And substitution rule, when do we use substitution rule? If it's a product of two functions and one is another one function, it's inside function's derivative. And actually 1 over y, nature log y, we know that one is another one is derivative, right? Which one? 1 over y is nature log y is derivative. So this one is derivative. So we will let it be our u. Okay? So we will let u be nature log y. Then consider its derivative. It's equal to 1 over y. And move it to right hand side. It's this one. So du equals 1 over y dy. 1 over y dy. So for this term we could rewrite it. is equal to, here is 1 over y times natural log y. So it's natural log y is natural log, sorry, natural log y is u. Natural log y is u. And the 1 over y dy is du. And y goes from 1 to 5. Then u goes from natural log 1 to natural log 5. But natural log 1 is 0, so natural log 1 is 0, and here is natural log 5 is 10. Okay, and what's the solution? The solution is natural log 3 subtract natural log 1 multiplied by, this guy is integral with u is integral with u squared divided by 2. U squared divided by 2. And u goes from 0 to natural log 5. So the solution is natural log 5 is squared divided by 2. Subtract 0 squared divided by 2, but it's 0. 0. And natural log 1 is 0. So finally the solution is natural log 3 times this guy. So it's 1/2 times natural log 3 times natural log 5 squared. It's our solution. It's our solution. Okay, it's our solution. Yeah. Okay. So in this example, we could see the note. So here, for this part, let me write down the note first. And finally, I will give you a concrete example. I mean, it's geometric meaning. It's geometric meaning example. For this example, you will see its geometric meaning. Now before that, like from this example, you could see this one, the note. For the double integral f of x y dA, for the double integral, if the function f is a product of two functions, I mean g of x times h of y dA, and it's our f of x y. Then for its double integral, we could separate. It's equal to ab gx dx times cd hy dy. This one. And here R is the rectangle ABCD times CD. This one. And the second part, third part is similar result. It's definitely integral or indefinitely integral. fxy plus gxy. Double integral we could separate, of course. We also could separate double integral g of xy dA. And for the constant, we also could separate. For the constant we could take out. And we set the last part. So for this part, they are similar. F is greater than G for all xy in R, the region R, then double integral fxy is greater than double integral g of xy. This one. Yeah, I think all of them are not as simple, are easy to understand. Otherwise, you could say just some similar result at definitely integral, single variable case, from single variable function case. Okay, so now let's talk about the last one example. The last example is the last one example in this section, and it contains the geometric meaning. So for you to prepare your final exam for chapter 12, it's the last example in chapter 12. For chapter 12, you should prepare the result. You should prepare the material in section 12.1. Yeah. for your final exam. So now let's see the last one example. Just find the value of the study. It's enclosed by the surface. Enclosed by the surface. G equals x times secant square y, and the plane. G equals 0, s equals 0, s equals 2, y equals 0, y equals pi over 4. These planes. And now let's see how to solve it. Yeah, how to solve it. Okay, so first of all, we should know the graph. I mean, of course, for this one, if you know its graph, you will know what does it mean. For its graph, actually, I just want to say, for this kind of equation, if you know how, actually, if you know its mathematical form, I mean, if you could write it down by mathematical way, by mathematical equation, then probably you could solve it, just follow our previous example to solve it. But the question is that if I give you a concrete example, this one, you should know how to transfer it into mathematical language, how to transfer it. Okay, so now let's see how to solve it. But so that's the reason why I say probably it will be better to just grab it, yeah. I mean, but it's not very difficult. It's not very difficult to grab it. At least you could grab the. We have some plane, right? S equals 0, s equals 2. So it's our 0, 1, 2. This one. And the y equals 0, y equals 4 pi. Probably it's 4 pi here. Okay. Okay, so originally we can view it this way here. We have 4 pi, 1, 2. Here is 1, 2. 2. Here is x, y, g. So s equals 2. The plane s equals 0, s equals 2. And the plane y equals 0, y equals 4 pi. So it means this one. But s equals, yeah. And g is this guy. And another one is g equals 0. G equals 0, it means the xy plane. G equals 0, it means xy plane. And g equals this one. Here you could see that s is between 0 and 2. So s is greater than 0. So this part is positive. Secant square, it will be positive. It will be positive. So for this function, its surface when s is between 0 and 2, this function, it must be positive. So you could view it this way, it's a positive. So probably you could view it this way. It's like the form. It's something like the form. For example, here, this one. And probably you will better. I mean, probably you don't need to, maybe you don't need to graph it, but if you know the graph, you will know what does it mean. If you know, actually it means this graph. G is this guy. G equals s times secant square. So the question is that we want to figure out the value. We want to figure out this study is value. This study is value. We want to figure out this study is value. So it's value. Double integral. R. Region R. Which one? 0 to 0 pi over 4. Right? So the region R is 0 to times 0 pi over 4. It's the region. And here, the function g equals f of x, y. So here this part is put the function f of x, y. So the function is x times secant square y. X times secant square y dA. So our question is this one. Figure out the value of the study in this one. It's our f of x, y, the area, and the double integral is double integral I over here. And as we said, it's not easy to solve it by double integral its definition directly, but by Fubini, we know that we could integrate it by x. Firstly, we could integrate it by x firstly, and after that integrate by y. Right? And the x between 0 and 2, and the y between 0 and pi over 4 to solve it. And of course, you could say that, well, I also could solve it, could integrate by x by y directly, firstly, right? I could integrate by y firstly, and after that integrate by x. And the y goes from 0 pi over 4, and the x goes from 0 to, right? It's fine. For this question, it's fine. If you solve it by this way, it's fine. And of course, you could solve it by this way or this way. That's fine. Okay. And actually, for this question, you will see it's a product of two functions. So when you solve it, actually you could separate. Otherwise, you also should do it 10 by 10. I mean, consider its integral. So second square y is a constant. You could view y as a constant, right? View y as a constant. View it as a constant. So second square times y, just keep it. It's a constant, so just keep it. And consider x is integral. S is integral in s squared over 2. S squared over 2 is 10. And here s goes from 0 to 2. S goes from 0 to 2 dy. S goes from 0 to 2. And then it's equal to 0 pi over 4. Just plug in the value, so it's second square y times 2 square is 4. 4 over 2 is 2. Subtract 0 over 2, so it's 0. This 10 dy. And then it's equal to 2. This one. And what's this? It's equal to 2, just constant, keep it. And second square, which function is derivative is second square? Tangent, okay? So tangent y is derivative equals second square. So we should use the formula. So it comes from tangent y. And tangent y goes from 0 to pi over 4. So finally, the solution is 2 times tangent pi over 4. Subtract tangent 0. This one. And tangent pi over 4 is 45 degrees. Pi over 4 is 45 degrees. So it's 1 square root of 2. So tangent pi over 4 is 1 over 1. So it's 1 over 1, so it's 1. And the tangent 0 is sine 0 over cosine 0. Sine 0 over cosine 0, so it's 0 over 1, so it's 0. So finally, the solution is 2 times 1, 2. Okay. So it means that the volume of this study is 2. Okay, so it's the last example in this section.